On the figure below, sketch the terminal ray of the angle that has a sine value of negative 0.5. So first, let's review what sine theta and cosine theta represents. Okay. So sine theta, so first, input is the angle theta, right? So the input can be thought of as the angle theta, which is this angle right here. Or again, same, all these are same angle, right? But I'm just going to choose this arc length because arc length divided by radius length gives us the angle. Okay. So this is the input. Input, and input is angle in radian, right? In radian. So that's the input. And what does this sine represent? Right? So sine of this input, right? Let's say this length is y, and let's say this radius is 1. Sine of this input represents y over the radius length. So in this case, radius is 1, so in this case, just y. What does cosine represent? Cosine represents if this length is x, or we usually use this length, right? This is how we measure it, which is same thing if we want to form a triangle, this length. So cosine is this length divided by radius, which in this case, for this picture, is x because this radius is 1 here and here. But not always, radius is not always 1, but in this picture, radius is 1. Okay. So then this is asking us to sketch a terminal of angle. So essentially draw an angle. Draw an angle such that sine value has negative 0.5. So we can assume, since it doesn't specify the radius length, we can assume radius is 1 in this circle. Okay, so radius is 1. We can assume that since it doesn't specify. So then sine value has negative 0.5. Since sine value means y value, right? This is how we approach this problem. Here we know this length is 1. Right? Negative 1 in terms of things going down, right? Length is 1, but in terms of coordinate is negative 1. So if we do here, this length is negative 0.5. So if I have an angle that ends right here, right? So I can draw like this. So for example, either this angle or this angle, both have coterminal ray. This angle will give us sine of negative 0.5. Similarly, another one here that ends here. So in this case, we have 2. So this angle, so let me draw a different color. Like this angle or this angle. But again, it's only asking us to write terminal rays, right? So you don't technically have to like mark an angle, just a terminal ray. So answer is these two right here, this terminal ray and this terminal ray. Angle that has these two as a terminal ray will give us sine of negative 0.5. In the figure below, sketch a terminal ray of the angle that has cosine value of negative 0.5. So since it doesn't specify, let's assume that radius length is 1. And since cosine is negative 0.5, that means the horizontal distance, right? So here is negative 1, the length negative 1, and here will be maybe negative 0.5. So this length is negative 0.5. So the angle that ends in terminal right here, so like here or here, so like this angle right here, for example, this angle or this angle again, they both have terminal ray, or this angle. So these two terminal rays, angle with these two terminal rays would give us sine of negative 0.5. Since radius is 1, right? Negative 0.5 divided by 1 gives us cosine. Sorry, I said sine earlier. Cosine. Negative 0.5 divided by 1 will give us cosine of negative 0.5, since this length is negative 0.5. So let me highlight the answer. Just looking for one of these terminal array. Find the exact values. So these are inverse trig functions. And although we will be using or will be referencing the unit circle, it is a little different. All these must have only one answer because these are inverse functions. Each input must give us only one answer. That's why, as you may already know, we restrict the angle for each inverse trig functions, right? So for cosine, we only look at top half of the unit circle. Right? For arc sine and arc tangent, we look at right half, right? Like these. But not only that, we look at these as a negative angle. So this right here is negative pi over 2. This is negative pi over 4, negative pi over 3, negative pi over 6. So for arc sine and arc tangent, the answer must be between negative pi over 2 and positive pi over 2, including these. For arc cosine, answer must be between 0 and pi. Like this. So when we look at this, this is asking what arc length will give us cosine of that arc, negative half. So essentially, what angle will give us such that cosine of that angle is negative half in this range. This is implied. When you see r is implied, it's in this range. It's not going to specifically ask you that find between 0 and pi because it's already implied when you see r cosine. Okay, so then on the unit circle is this angle right here, right, which is 2 pi over 3. So this answer is just 2 pi over 3. Okay. But again, you must remember to only look at between 0 and pi. If you write this answer right here, 4 pi over 3, that is incorrect. It's only this answer. So then let's look at arc sine of negative square 3 over 2. So again, we are referring to unit circle. And on unit circle, 5 pi over 3, sine of 5 pi over 3 will give us negative square 3 over 2. 5 pi over 3 is located here. Located right here. But we cannot write 5 pi over 3 because it has to be between this in range. So we instead of using this angle right here, we use this angle. Still coterminal, which is, we write it as negative pi over 3. So this one is negative pi over 3. How about sine inverse of negative half? Okay, we refer to unit circle. On unit circle, 11 pi over 6, which is located right here, will give us sine of 11 pi over 6 is negative half. But again, we cannot write 11 pi over 6 as an answer because 11 pi over 6 is out of this range right here. So what we have to do is we write negative angle. So instead of writing this 11 pi over 6, instead of writing this angle, we write this angle, negative pi over 6. So negative pi over 6. So let's look at tangent inverse negative square 3. So this is essentially asking what angle such that sine theta of cosine theta, because that's one way we can find this tangent, right? Which is essentially finding slope, will give us negative square 3. In this range, again, this is always implied for all the inverse trig function. This range for sine inverse, tangent inverse, this range for cosine inverse. So we have the theta we find here must be between negative pi over 2 and positive pi over 2. So on the unit circle, we know that 11 pi over 6, for example. So let me do it here. Tangent, oops, sorry. Sine of 11 pi over 6, cosine of 11 pi over 6 will give us sine 11 pi over 6. Oh, actually, I picked the wrong angle, sorry. Let me write that again. It's actually 5 pi over 3, right? 5 pi over 3 over cosine 5 pi over 3 gives us negative square 3 over 2 over 1/2, which is negative square 3. So you look at this and you know what? 5 pi over 3 must be the answer. Well, no, 5 pi over 3 is out of this range. 5 pi over 3, let me draw it here. This angle right here is 5 pi over 3. But since this is out of range, we write another equivalent coterminal angle, this one right here, this one, which is negative pi over 3. So answer to this is negative pi over 3. You cannot write 5 pi over 3. You can reference 5 pi over 3 to locate on the unit circle, but when you write the answers, you have to make sure it's in this range. So let's look at tangent inverse of 1. So which angle on unit circle says the slope is 1? That's this right here, right? Use different color right here. Here we have square 2 over 2, square 2 over 2 for sine and cosine. So if I find the slope here is 1. So what is this angle? Pi over 4. So this answer is pi over 4. Again, this is still in this range, so we're good.